Good morning, everyone. It's Hayden here with Whitewolf Foam and Forge. Trying to get my light adjusted a little bit here. So, I was talking with some people this weekend at Mecchia while we were at Park, and there were some suggestions for stuff I could do. A lot of people seem really interested in my Arrowhead work. And one of the things I have with me today are some new arrowheads I worked on last night. This is the standard arrow core I've been using. It's also one that's very common with people here in the area. I actually learned this design from Cade Moonshadow Mander. If any of you guys are Amtgarders and know of him, good guy. Basically, it's just a 3/8 inch PEX pipe core. PEX stands for polyethylene cross-linked. It is just a polyethylene plastic that has been linked up a certain way to, or molded a certain way to increase the strength of the bonds and stuff. It's a lot more flexible, I think. This is a sample of it than regular PVC, but I feel it's also a lot stronger. I can do all kinds of weird shit and nothing happens to it. So this is what I've been using for my standard core material for about a year now, since I learned the original design from Cade. The end is a washer, 1/8 by 1 inch zinc washer. You can get a pack of these for $8 of 100. Well, it's about $9 at Home Depot. And then to form the screw, which will screw into your arrow shaft, of course I thread it through the washer, but it is a number 8/32 by 1 3/4 inch machine screw. I prefer the truss head. You could go with other heads, round head or whatever, but the truss head is a little bit flatter, and I think it definitely serves the purposes here a little bit better. I don't know if my camera's going to focus on it very well, but that's the screw. And then I thread those, of course, through a number 8/32. I just had a bunch of nuts go all over the place. Machine nut. You will need to do it for the machine screws. And it is, once again, a zinc nut, like the washer head. The machine screws, I do believe, are... No, they're zinc as well, so I thought they were stainless for some reason. You can get them in stainless. I don't know if it's going to make any difference at this point, as far as everything. And I know the stainless comes a little bit more expensive than zinc. So I highly recommend the zinc nuts, screws, and washers for this project. Now, previous iterations I've used in the past of this same build have used, well, they've all used JB Weld to cap them. This is your standard JB Weld. It is 2 parts epoxy, of course. It is a steel resin, which is basically just a resin impregnated with steel. Very strong, around 5,000 psi of bond force, and it's pretty good. This is, of course, the hardener for the resin, which, you know, reacts with the stuff in here to basically keep it from being soft anymore. So it goes from pliable to hard, and I tell you what, when it's hard, it's hard. You can't get it to move. Anybody who's used this stuff knows all about it. Now, for this set that I am doing currently, which is this guy, you'll notice there's none of that black and gray telltale sign of being JB welded, with regular JB Weld at least. My cousin set me onto this. It is the JB Weld plastic bonder. It's supposed to be for metal to metal and plastic, or metal to plastic and plastic to metal plastic to plastic and metal to plastic applications. So obviously you can see where we might want that here, because you're taking a metal washer and a screw and a nut and you're bonding them to a plastic. So what I did is I mixed a little bit of it up and applied it in the same way I do that. Apply a little bit of heat to the end of my washer with my heat gun, which if you don't have a heat gun, you might be able to get away with it, but I highly recommend a heat gun for any of these projects. You just never know when you're going to need a little bit of heat to get something to move or to form or something. So heat gun, number one. This is like 15 bucks at Harbor Freight, and hopefully it'll last for a while. So I've heard some people use them 6 months at a time. I've heard some people use them for years. I don't know, depends on your use. And then so anyway, I made my bead around the edge here. Let me get my hand out of the way. And as you can tell, it seems to have set up. It does say it bonds to a hard bond. These are still kind of soft at this point. I think that may have something to do with the weather. It recommends. So yeah, one of the reasons I would look at the plastic bond was because it was supposed to be for plastic to metal, which was my definite use here. And I'm trying to make these things as safe as I can. This is coming from the manufacturer's application. It sets in 15 minutes with a cure time of 30 minutes with temperature below 40 degrees, and set time can be longer. I don't know how long it took these to set. I basically did them up last night and then left them until this morning. So they've had roughly 12 hours to cure at this point, where JB Weld typically takes at least 24 to fully cure. So I'm really hoping this is a new thing, this core. So essentially is what I do. I'm going to run through the process real fast. It's a good one. Let me sand this down real fast. So another tool that, if you don't have it for your workshop, that I cannot stress enough now that I've finally acquired one, Dremel. Dremel, 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 Dremel. You can use it to sand. You can use it to cut. You can use it to polish. You can use it to pick your nose. Don't do that last one. I feel like I need to say that for some people. So essentially you have the Dremel, and I got this one for $12.88. No, I'm sorry, $18.30 something, almost $19, almost $20 to say, at Walmart. It is a 1.5 amp rotary tool. The kit comes with 106 parts, including this guy. They also had a cordless one for about 25, I think. Didn't have as many bits with it, but it was cordless, so that might be something for some people. Me, I'm usually near electricity, and that's okay. I might acquire that at some point, though. But it comes with this cool little carry case. Inside, let me show this guy off real fast. You know, inside you have, of course, your cutout for the tool itself, and then the cord. And then you have a little box full of all your tools. So you have polishing disc, you have cutting disc, you have polishing, cutting, grinding, all the little bits and pieces you can do, all in that little box. Great tool. So we'll see how long it lasts. It's a Walmart branded thing. It's not an actual Dremel, but you know, if it works, it works at this point. I'm not getting caught up on the brand. Also, this morning brought to you by Folgers Coffee. Woohoo! I love my coffee, y'all. I also picked this up, 40-piece grinding and sanding set. It was like another $8 for that, and you got a few more polishing wheels and stuff. So, yeah. I want to make sure I was set up to do a lot of sanding and polishing and grinding edges. So yeah, that's the tools you'll need for this part. Now, as far as cutting the pipe, I'm not going to go through all that. Cutting pipe is easy. If you really need that much help with it, message me. I'll walk you through it. But basically what I do is I cut my pecs to a 3-inch. Sorry if I seem like I'm wandering here. Ah, there it is. I cut the pecs to a, I really need to get a big number ruler. 3 inches or thereabouts. Okay. So with that cut, now this step is optional, but your cuts aren't always going to be straight, so this is what the Dremel's for here. So we turn this bad boy on, and I just make sure my edges are nice and smooth. Yeah. There we go. So there's a little bit of burring on there. We'll clean that up real fast with some actual sandpaper. But the idea of that is to get your cut smooth and flat, so that when you go to actually put your plastic bond on, it doesn't get in your way. So get rid of some of that burring. Awesome. It also gives you a little bit more surface to make the plastic bond with. Sorry, I just missed a notification. So then you take the tube, and you can touch up this edge if you want to. That's the edge that's going to be on your, it's going to be pointing down your arrow shaft. I don't really recommend always doing it, but, so you take your plastic bond, and the cool thing is it comes in this neat little syringe, which helps you dole out equal amounts of the substances. And you just take it and you just push down a little bit and get a little bit out, a little bit more. And it's supposed to dole it out in equal amounts, theoretically. There we go. Alright. And then I always do, just like you should with any syringe, I do a little bit of a pullback on there. The idea, as with any syringe, is to, you know, suck some of that back in. And then I always redo the cap immediately, so as to prevent any drying out of the material. This is about $6 a tube, so you don't want to misuse it if at all possible. And you just kind of take your popsicle stick. This is the one I used last night for doing this same operation, and you just kind of mix it all together. Unlike JB Weld, which goes from black and a white to kind of a grayish mass, this just goes from a off-white mass to another off-white mass. But you can kind of tell when it's all mixed together. There's little striations and stuff that disappear. So once you have that epoxy done, you then take a little bit of it, and like I said, you want to do your heat gun. So we're going to take the heat gun. This is one of the cores. I did use JB Weld on these cores because it all is all metal to metal. So all those arrow assemblies are done. I have 4 of them over here actually waiting to be used. So turn on the heat gun, takes it a minute. I actually usually do this with it, which is set it up here on the desk, and I just kind of gently heat it. Set that there. You want to be careful when using a heat gun. I'm being dumb here and not using a glove. Also with the Dremel, you should probably wear eye protection. I just wear my glasses because they cover a good bit of my face. I do have actual safety glasses for when I'm working with metal, because I have had metal shavings flung at my face before, and yeah, that's not fun. So soft eyes and stuff and metal shavings don't mix. So yeah, and then you just want to heat that until it's pliable. You'll know, and then bam, just set. See, once it's pliable, give it another second. You just set the screw in there, and I'm going to check the bottom, make sure that it's flat, and now it is set in there. So what will happen is over the next few moments, while it cools, it will shrink a little bit, but that's not going to be enough to actually do anything to keep it in. So that's where the JB Weld comes in. So you take a little bit of the JB Weld, and I always make a bead around the top of the core. And then I take this and I set it back in there into the groove I just made, and then you kind of want to check your end. You want to check the end to make sure that your screw is straight, because sometimes, like I had that one with the offcut where before I ground it down, that can cause issues there. And then I just take my popsicle stick again, and I just run along the edge of that bead. And the idea is to get as much epoxy in there as I can. And there, the epoxy is now been applied. I'm going to give this a little bit to dry. So while I let them dry, I do set them to the side here on the bench, and they'll just hang out there for a little bit. Since I have a couple of them here and ready, I'm going to go ahead and take care of those while I'm sitting here not doing anything today. I have two more of these cores. Actually, I technically have a third because I took one apart last night. Yeah. So this was actually one I'd previously built. It has a slightly longer section. I'll cut it down post all this. But this was actually one of the first cores I made last year with Cade. It did fail because I think of the JB Weld and me not knowing what I was doing at the time. So yeah, and as you can see, you just get that little edge. Looks good. Once again, So the idea is I'm not wanting to waste this plastic bond I have made up right now. You don't ever want to waste plastic bond or any kind of material if you can help it. I've gotten better at figuring out exactly how much of what I need and using it, or I find a use for it, because you don't want to waste material, not in this economy. But you know, some people who have more money than me might be willing to do so, but that's cool. Whatever your flex is. So yeah. That said, I will be testing these arrows ridiculously to prove the viability of their safety with the plastic bond as opposed to regular JB Weld. With the intent that I want to make these kind of a standard at the least for the field within Winter's Edge and within Amtgard as a whole, having that level of safety. So, thank you from Whitewolf Foam Forge and Armory. This is Hayden. Stay tuned for my next tutorial, which will include the actual wrapping of the heads with foam and the application of the entire tip, which will be a safety tip that I have been working on. Thank you.